Okay, back to the exam debrief. We're now looking at these equations. This is a linear equation. It says solve for A. And by the way, problem 59 was quadratic. Let's see, problem 60 was also a linear equation. So this one and problem 60 are solved the same way. How do you solve linear equations? First of all, you look at all the terms in the equation. Remember, terms are separated by plus and minus signs. So that's a term. This is a term, the plus b. The 5 is a term. The minus ab is a term. And the plus a is also a term. So we have 5 terms. And then because we're solving for a, we identify the terms that actually have a in it. So these are the terms that have a. And the procedure here, in 3 simple words, is to move all the terms that have what you're looking for to one side. And then we're going to factor. We'll factor out the term that we're looking for, or the expression that we're looking for. And then we'll divide. So move, factor, divide for all linear equations. This is how you solve them. So let's see how it plays out for this problem. Okay, we're going to move all the a's. Let's move them to the left. It really doesn't much matter which side you move them to. We have 2a. We're going to move the ab over, so that's plus ab. And we'll move this a over, so that's minus a. And then on the right side, we had a 5, but now we're going to have to move the b over, so that's minus b. So we've taken care of this move step. Second step, factor. Actually, we could simplify a little bit. Notice that we can collect like terms. The 2a and the minus a combined to just give us 1a. So if we clean this up a little bit, we have a plus ab is 5 minus b. Right? 2a take away an a is just a single a. And then it says to factor. Okay, so to factor, all the terms on this side have an a in it. And the reason we know that is because we moved them there, right? All the ones that have a's are on the left. So we'll factor out the a, 1 plus b. So we've completed the factor step. And then lastly, we have to divide. We're trying to solve for a, so we'll divide both sides of this equation by 1 plus b. 1 plus b. Okay? And common factors cancel. So 5 minus b over 1 plus b. Choice B. Linear equations, basic idea. We do that a lot in advanced mathematics. Let's go to problem 60 because this was also linear. And so again, we're thinking move, factor, divide. Move, factor, divide. This time we're solving for x. So we're looking for all the terms that have x in it. This has an x and this has an x. So we'll move those to one side. 3x minus root 2x. And then all the terms that do not have x would go to the other side. So we have 1 plus 2. Cleaning that up a little bit, 3x minus root 2x is equal to 3. We've moved and cleaned up. Now we go ahead and factor. We'll factor out the x. Both of these terms have an x in it. X comes out, 3 minus root 2. And that takes care of that. And the last step is to divide. So we divide both sides by 3 minus root 2. So x is equal to 3 over 3 minus root 2. It was sort of disappointing the number of people that could not solve a linear equation. Linear equations. Okay. After problem 55, we had this power equation, right? And the way you solve power equations is to raise both sides to the reciprocal power. So we have the 3/2 power, and that's equal to 8. Raising both sides to the reciprocal of 3/2 would be raising to the 2/3 power. To the 2/3 power. Now think about what we're doing here. When we raise to the 2/3 power, we are in fact taking a cube root. Remember, the roots are on the bottom. This 3 indicates this is a cube root. So we're taking the cube root of both sides, and then we're squaring the result. That's what the 2 does. Okay, so by doing that, on the left side we have x to the first, or simply x, and on the right side we have the cube root of 8 squared. And I might be asking me, is that 2 under the radical sign or not? Did you mean the cube root of 8 squared? Is that what you meant? Or did you mean the cube root of 8 squared, like that? And the answer is that they're exactly the same. It doesn't matter. So if we go this route, we're finding the cube root of 64, which is 4. And if we're going this route, we're taking 2 and we're squaring it, which is 4. Generally speaking, it's easier to put the exponent on the outside because you're dealing with smaller numbers, right? So here the biggest number was 8. Here we had to deal with the 64. Okay, so the answer is 4. And by the by, you might want to just, think of some variations of this. What happens if we had x raised to the 2/3 power and we're trying to solve that equation? That wasn't the one that was on the exam, but it might be on Friday's test. X to the 2/3, and let's say this was equal to 4, just so that we can play with some numbers. We raise both sides to the reciprocal power, which is the 3/2. But now, again, think about what we just did. We just took the square root. That's the square root of both sides. And whenever you take the square root of both sides of an equation, you must include both the positive and the negative root. So on the left side, we get x, and on the right side, we get plus or minus. This is the square root of 4 cubed. So plus or minus 2 cubed plus or minus 8. Okay? And sometimes you'll have equations that have no solution. Certainly if this, for example, was this problem here, x raised to the 2/3 is equal to -4. This was the problem. This has no solution. And you'll see it immediately as soon as you raise both sides to the reciprocal power. We are now trying to take the square root, right? The root's on the bottom right here, the square root of a negative number, not real. So this one would have no solution. Power equations. Okay, number 57, this is our log equation. Again, we worked with these recently. Here was my translation key for those folks that wanted to do it this way. The 10 squared is 100, says 10 times 10 is 100. Log base 10 of 100 is 2, says 10 times 10 is 100. We have a log equation here, so it's going to go over on this side. Unfortunately, we've got this log base 2 of x plus 5. Let's chuck the 5 across to begin with. So we have log base 2 of x is equal to -3, right? By moving the 5 over, subtract 5 from both sides. And then the translation, 2 raised to the -3 power is equal to x. And as long as you know what negative exponents work, how they work, this is pretty straightforward. This is 1 over 2 cubed, which is 1 over 8. Okay? 1/8, choice C. Number 58, solve for t. Now, I had a lot of people on this exam say the answer was the natural log of 0, and that's not a number. If we actually try to say, Mr. Calculator, what is the natural log of 0? It says it's not in the domain. Remember, the log function graphs like this, and the domain is all the x's bigger than 0. So the log of 0 is meaningless. That has no answer there. So what's going on here? We have this exponential graph. Y is equal to e to the t. Let me go ahead and graph that. This now is my t-axis. This is my y-axis. And the exponential graphs look like this, right? Passing through the point 0, 1. And the question is, where does this thing equal 0? Where does e to the t equal 0? So if I put my eyeball out here on the axis, here's my eyeball, and I look at the graph, nowhere will this equal 0, right? There is no solution. The exponential is always positive, right? The range is positive real numbers only. So this equation, e to the t equals 0, has no solution. That's the correct answer there. Okay. 59, solve for x. Well, here's our good old quadratic equation. Hopefully you can do this pretty quickly. X is the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And here it is here. Okay. Be careful, the fraction bar does need to go all the way over, so choice C was not correct because that was not there. And all the other ones had errors of one type or another. And the opposite of b plus or minus b squared minus 4ac all over 2a. Algebra 1. 60 we already did. Here's 61. This is a log expression, and again, I'll use my translation key here. 10 squared is 100, translates as log base 10 of 100 is 2. We have a log expression here. We have log base e of 3x minus 1 is equal to 1. Here's the translation. E to the first power is 3x minus 1. Or if you want, e is 3x minus 1. Okay, so we've translated the log to the exponential form. Unfortunately, the question was solve for x. So at this point, we're linear and just get the x by itself. We'll chuck the 1 over, e plus 1, and then we'll go ahead and divide by 3. Okay, e plus 1 over 3. Okay. And the choice D is the answer. By the way, note this, when you see natural log of an expression, that's using the natural base. So these two mean the same thing. Most logarithms in advanced mathematics are using the natural base. And in fact, in most advanced courses, when you say log, you mean the natural base. In this class, we'll be very particular and just use the natural log idea. Okay, 62, this is a exponential equation. Well, sort of. If we have 10 squared, that's 100. Log base 10 of 100 is 2, and we know that. Here we have a 2 in front, which is sort of bothersome. So let's get rid of that first. We have 2 times 3 to the x is 5. Divide both sides by 2. 3 to the x is 5 halves. Okay, remember order of operations. No, you cannot write 6 to the x. Now, you always have to carry the exponential part, the exponents, before you do multiplication. So once we've done that, then we can go ahead and translate. Here's our exponential form, and it will translate as log base 3 of 5 halves is equal to x. Choice E. And there's other ways you could write that, but in fact, this is the only one of the 5 choices that is correct. 63, find all solutions. Okay, so this is now our zero factor theorem type problem. I think we actually saw this in the warm-up. First thing we do is we set this equal to 0. Plus 2x is equal to 0. Then we factor. So x times x squared plus 2 is equal to 0. And then because we have 2 quantities multiplied together giving us 0, one of them has to be 0. Or the other one has to be 0. Now on this side, x squared plus 2, if we try to make that equal to 0, that says x squared is negative 2, and we know that's non-real, right? That would be plus or minus the square root of 2i. So we're only dealing with real numbers here. So the only solution is, in fact, x is equal to 0. X is equal to 0. Okay. If, in fact, this original problem had x cubed is equal to 2x, like that. Let's see if we can suppose the original problem was this, and now the task is to solve. Again, we go the same approach. X cubed minus 2x is equal to 0. We factor out the x. x squared minus 2 is equal to 0. Either x is equal to 0 or x squared minus 2 is equal to 0. X squared is 2. X would be plus or minus the square root of 2. There would be 3 solutions to this modified equation. You did not have that on the exam, but you might see it Friday. Okay, so those were our equations to solve. Let's stop this video here. We'll pick up the rational expression on another video.